Hey guys, welcome to my demonstration video. This is my vehicle and service parts management system, or VSPMS. And the major goal of this project was to demonstrate that I understand how data structures work internally and not just how Python's built-in libraries. And instead of relying on structures such as Python dictionaries, list queues, and priority queue, I kind of wrote my own implementation of each data structure and connected them to each practical vehicle service task. So here I can show you my code and was down of all like the data structures I use here: max heap, queue, stacks, hash map, graphs, which I'll explain further in the video. So here is my application. Here I used Streamlit. The front end, yeah, it was built with Streamlit, and it handles, and while the Fast API handles the backend routes and communication between the interface and the data structures. And this project also implements the RAG retrieval augmented generation system, or a RAG system, where a user can upload a vehicle manual, such as like a PDF, and document is split into text sessions and converted into vector embeddings using OpenAI and stored into Quadrant, which is like a container, online container, and ingest manages the background ingestion workflow, which I could keep track of my functions right here. And it was a lot easier to use this for the debugging, especially for the AI part and the RAG augmented system. So when a user asks a question, the question is also converted into the embedding, and the quadrant searches for the most relevant sections of the manual, and those sections are passed to AI as context. So and then after that, the AI generates an answer based on the uploaded manual instead of relying on general knowledge. So yeah, and here if I can, this pretty simple UI. Here I use a stack, nothing too complex. Shaq is coming to town, and you can undo it, redo it, right? Or undo it, redo it, or just process it just like how you would on deployment using a stack. And my parts inventory, here I use a hash map for the exact lookup because that's 0.1 speed, and I use a hash map just to order everything, so they kind of work together. So here I can add a part 500, and let's say car door. Add that part. Can search it using the hash map. Car door exists, right? Can delete the car door. And here from range, I have to iterate and see, maximum, minimum part number, and find all the items between this range right here, right? Nothing too crazy. Here I have my priority pairs. Here I use a max heap. So I could add my name, Jude. I drive a Ford F-150, and based on these services, they all have a different priority. So let's say I have a fuel leak, it's not drivable, and it has an active leak. So add that and have the highest priority in this list. But if I was, let's say Juke, Prius, whatever, right? Air filter replacement is drivable, does not have an active leak. Add that, and you see we're here, where the priority is. So I can, view the highest priority, which is me. It's the 150, and I can process it. Repair logs, pretty simple, just a linked list. I'm not gonna go too in depth with this. Let's say oil change Jude. Pin the repair log with the coordinating date, And here I have my repair processes, which these are all just built in. I just put in initialize a list in my code. So fuel leak, and I have all these connected through a graph. It's a directed graph, so they all point to the next step. And the estimated time are just the weights between the distances between each node. Here's the compute graph or workflow you can see, and the traversal if you like using the searches. Let's get into the good stuff right here, which is the RAG. And here we can upload a car manual, any car manual, doesn't matter. I just use a Ford F-150 right here. And let's see, ask it the question specific to this manual, which is what is the engine present in this vehicle and what page can I find it. And here I have a chunks where I just asked how many, or this asked how many chunks I need to retrieve in the quadrant when I look for this data. When the quadrant is a container that has my database inside, or container inside Docker, which is my database is quadrant. And those are all the vectors, I look through to find this information. So sending event, generating answer. And like I said, I use OpenAI as my LLM. So here we go. Engine has a 3.5 liter EcoBoost engine. You can find it on page 527. Pretty neat, right? Here I'll go into my code a little bit. Everything is on my GitHub. Every single step, I have a whole README and everything. All of it is documented. I just completed it or finished everything recently. Here you can see the functions right here. Successfully ran. Everything's going well using ingest for my debugging. And go a little bit into my data or my code. So this is the main RAG search kind of code. I use GPT-4 mini. Here's my question. Here's my my content. Only answer question using the provided context. And yeah, my initializer or connected to my ingest. And yeah, pretty much just have the payload that sends it back. It goes to the vector DB, splits it up. One problem I did have with my vector is when a file would be too big, there would be too many tokens. And a problem I ran into is that when I would try to upload all those tokens at once up to the database, it would, time out because there's only so many tokens that come in at once. So what I had to do was batch it down and send it through batches. But other than that, everything went pretty smooth. And yeah, thank you for watching.